Now we're in section 4.4, and this is on exponential and logarithmic equations. And with these four examples, I'm going to first show you how to solve these exponential equations by expressing each side of the equation as a power of the same base and then equating the exponents. So you'll notice that 81 is 3 to the fourth power. So I can write this equation as 3x equals 3 to the fourth power. Now that we have the same base on either side of the equation, I can then conclude that the exponents must be equal if the exponential expressions are equal. So I just conclude then that x equals 4. Here, 27 is 3 cubed. So I have 3 to the 2x plus 1 power equals 3 cubed. And now that the bases are the same, I conclude that 2x plus 1 equals 3. And then I just have a linear equation to solve. Subtracting 1 from each side, I get that 2x equals 2. And then dividing both sides by 2, I get x equals 1. In this example, notice that 125 is 5 to the power of 3, but we're raising that then again to the xth power. And 625 is 5 to the fourth power. Well, before we can proceed, we need to combine this into a single exponent. We have an exponent raised to another exponent, and so we need to multiply the exponents. And this gives us 5 to the power of 3x is equal to 5 to the fourth. The bases are the same, so I conclude that 3x is equal to 4. And dividing both sides by 3, I have x equals 4/3. Finally, notice that I have a fraction here. And 125 is 5 cubed, but it's in the exponent. So that means 5 to the 2 minus x is equal to 5 to the negative 3 power. This negative just means I take the reciprocal, and the 3 means I'm taking 5 cubed, which is 125. So the reciprocal of 125 gives me 1 over 125. Now that the bases are the same, I can set the two exponents equal. And solving now for x, I'm going to subtract 2 from both sides, and I get negative x equals negative 5. And then multiplying both sides by a negative gives me x is equal to 5.